You can identify transformations to the parent function, and we're going to learn vertex form. So quadratic transformations to the parent function. First, you have to remember this is the parent function. That means the vertex is at 0, 0, and it looks like this. It goes up. So when it flips upside down, that's called a reflection. And the way you can identify it is there's always going to be a negative in front of it. Then a horizontal shift, and this was my mistake. That should have been a minus. This should have been a plus. So the horizontal shift is going to be in parentheses, and it's the opposite of what you think. So a minus would mean to the right. A plus would mean to the left. Vertical shift, you add a number to the end of it, not in parentheses. Left and right's always in parentheses. So positive means it moved up. So what is it moving? Negative means it moved down. It's moving the vertex. It's moving the vertex around. So a stretch, you're going to have a number in front of parentheses where a is greater than 1. The number's bigger than 1. Stretch means it makes it narrow. And then a compression means it makes it wider. And the number in front of that will be between 0 and 1, which is a fraction. So let's look at these equations and see what transformations there were. This negative tells me that there was a reflection. In other words, a flip upside down. The minus 4 tells me it went down 4. So if I were going to sketch this, whereas the parent function sits here with a vertex at 0, 0, this says that this one, the vertex moved down 4, and the graph flipped upside down. So it looks like that. The next one, the 2, tells me that there was a stretch. That means it got narrower. And then that doesn't look right. There. The plus 3 in parentheses means right or left. And because it's the opposite of what you think, the plus means it went left 3. So this one, the vertex moved to the left 3, and it got skinny. So if we wanted to sketch it, that's what it would look like. This next one, the negative, tells me there's a reflection. The fraction tells me there's a compression. That means it got wider. And then the minus 8 tells me it went down 8. The number next, the negative, tells me it's a reflection. The minus 5 in parentheses tells me that it went right 5. And the plus 1 tells me it went up 1. So we can go opposite. We can go backwards. I can tell you some transformations, and you can write an equation that fits that description. So y equals the reflection means I need a negative. The right move's going to be in parentheses, and the opposite, so it's going to be minus 4. And then down 5 is going to be outside of parentheses. The compression, you can just make up a fraction here. So let's say like 3/4 x squared plus 2, because it went up 2. We didn't need parentheses because there wasn't a right or left move. A stretch would be a number bigger than 1, maybe 5, but it's a reflection, so it needs to be negative 5. Left 3 is going to be in parentheses, and left is usually negative, but I'm doing opposite, so plus 3. Now the vertex form is closely related to our transformations. Vertex form is there's a number in front, then there's x minus h, that's where the opposite comes in, plus k, and hk is your vertex. So on the parent function, There's no H or K, so the vertex is 0, 0. So this one, the vertex, is the opposite of what's in parentheses, so -3, and then it's this number for the y value, +1. The transformations that took place were a stretch, left 3 and up 1. Do you see how if I took that parent function and I went left 3 and up 1, then where's my vertex? -3, 1. Left 3, up 1, -3, 1. So they're closely related. Vertex here, the opposite of this, so 1 and 2. It had a reflection, the negative. It went right 1. The -1 tells me it went right 1 and up 2.